Here, 4-5, we are going to be looking at the graph of sine and cosine and kind of revisiting what some of the important parts of the equation is, what it does for our graph. All right, the first thing that we want to look at is just in general the domain of the unit circle. Here I've got my unit circle on my x and y axis. And so my unit circle obviously has a radius here of 1. So my domain would go from -1 to +1. And my range here also, since the radius is 1, will go from -1 to +1. All right, what the sine curve looks like. The sine curve, it just comes from the values on the unit circle. We can assume that all of the x values are the cosine and all the y values are the sine. And we can basically put those points to ordered pairs in order for us to be able to graph. Okay, we've got a general form. It's y equals a sine of bx plus c and then plus k. So all of these values will do something with our graph. The a is considered to be our amplitude. It's how high the graph is going to go and how low. The b is going to tell us how long it takes to repeat itself. The c is a shift left and right, and the k would be a shift up and down. So this would be a left or right shift, and this would be an up or down shift. The b tells you the length. It helps us tell us the length of it. And a is amplitude. And that's really the case for all of our trig functions. So amplitude here would be the coefficient in front, so my amplitude is 1. Here's how you find period length. It is taking the b value here. Since normally it takes our sine curve to go one full cycle in 2 pi, it's all the way around, it's 1 revolution, then we can figure out our length by doing 2 pi divided by b. So really what this is it's just a formula that we're going to use. 2 pi divided by b. In this case, it's 2 pi divided by 1, which equals 2 pi. All right, we're just graphing here the general sine curve, and so let's go ahead and look at the results. I know that sine of 0 is 0. This comes from the unit circle. And I know that sine of pi over 2 is the result of 1. I know that sine of pi is also 0. I know that sine of 3/2 pi is -1. And I know that sine of back to 2 pi is back to 0 again. So my graph forms this curve. Here it goes up to 1, back down through 0 and down to -1 for a minimum point, and then back to the 0 mark again. And then what we know is that it's just going to keep repeating over and over. It keeps repeating. These are 0. This was pi over 2. This was pi. These are called our critical points. 3/2 pi and 2 pi. I could keep going with my labels. The next mark would be 5/2 pi here, and so on. 5/2 pi. What we're going to notice here is this sine curve keeps repeating that curve throughout, going either direction. Okay, but these 5 points that I've labeled are called our critical points. It's where we consider what we call our generic box. The generic box is this. So this is where we would consider the graph to be its original, and then after that it keeps repeating. So where our graph starts is at 0. The first, or the quarter point, since it's broken up into 4 sections, is at pi over 2. These are considered to be our critical points. And then the midpoint's at pi. 3/4 point is at 3/2 pi. And then the end is at 2 pi. Now the only way that these are going to change is if the length of my period changes. So if your graph repeated itself more often than the 0 to 2 pi here. Okay. But these are the most important points right here. That's actually how we find a lot of our parts and where our graph crosses the axis. All right, let's go ahead and look at the next one, what cosine looks like. And maybe a lot of this you're going to remember, but y equals cosine x. My amplitude is 1. Okay, it's coming from the coefficient. Period length, you do 2 pi divided by b, which is 2 pi divided by 1, so 2 pi. Let's use the unit circle here to get a good sketch of this one. Just from 0 to 2 pi, because that's how long this is. So sine of 0 is 1, point here. Sine of pi over 2 is 0. Sine of pi is -1. Sine of 3/2 pi is 0, or cosine. These are all cosines. And then cosine of 2 pi is back to 1 again. So this is what my curve looks like here for cosine. And then it'll keep repeating. Past that mark, that keeps repeating. And also to the other side, it would keep repeating. Okay, but these are the most important parts. My graph, or the generic box, begins at 0. It has an x-intercept here at pi over 2. The midpoint is at pi, where it has its minimum point. And then 3/2 pi, it has another x-intercept. And then 2 pi, it starts over again. So those are the key points. So 0, pi over 2, pi. And you'll see that the sine and cosine curves have the same key points. There you go. So that is the graph of this. And we graphed it just from 0 to 2 pi. Okay. All right, let's see what happens when we start changing some of them. Okay, so the transformations with basic sine and cosine graphs. Here's another form that you might see. This D, again, is just going to be an up and down shift to it. If you have a reflection in your graph, any reflections would be if A was less than 0, then it's reflected about the x-axis. Okay, so this is your A value. Amplitude is also your A. It tells you how high the graph is going to go. The period, what it means is how long does it take to complete one cycle. And so for sine, this is one cycle right there. For cosine, this is one cycle. And you can see that the period length is how long it takes to complete one of those. And the phase shift, if your B is equal to 1, then C is the horizontal shift. Your phase shift comes from Bx minus C. It's actually found by taking the negative C over B. That's how you find the phase shift. It tells you the direction and how long it's shifted. All right, what we want to do is just look at, when something is changing on the graph. So here I've got y equals 2 sine x. Well, the 2 is going to affect the graph. What it does is it makes it go higher. So my amplitude is 2. But my period length has not changed. It's still 2 pi divided by 1, 1 being the coefficient on the x, so 2 pi. That's how long it's going to take. And since the period length is the same, then all of these points are the same. I also do not have any phase shift. Okay. So the difference between this graph and the last one is simply just the amplitude. So my graph is going to go up to 2 and down to -2. Okay, it still has those 4 important or key points, 5 initially because you start at 0, and then the first quarter point's pi over 2, and then the midpoint's at pi, and then you got 3/2 pi, and then we've got 2 pi. Okay, so we know what the sine curve looks like. The sine curve looks like this. It goes up and has a maximum point at pi over 2. It comes back down and crosses through at 0, -2 down at the third quarter point, and then back to 0 again. So the difference is the amplitude here from the x-axis going up is 2 units. And that 2 comes from the number in front. But my point, my 0 is where I start. I still have pi over 2 being my first quarter. Pi is your midpoint, 3/2 pi is the third quarter, and finally 2 pi is the end. Now this graph again would continue to repeat, and it would have the same type of pattern. Let's look at what happens when we have cosine of, again, 2x. So my amplitude is 2. Period length is still 2 pi. Excuse me, let's go back. That 2 is not in front of cosine. That 2 is in the middle here. My amplitude is 1. Period length, we go 2 pi divided by 2. So now my period length is pi units. And there's no phase shift here. In order for them to be a phase shift, you have to have bx plus or minus a c value. Here's my argument, is right in here. All right, so now what we've got to do is we need to figure out where do I start my curve, where the middle is, the first and third quarter, and the end. And I'm just graphing one period. Here's how you can do that. You can set the argument 2x equal to where it normally begins at 0. X would equal 0. My graph is going to begin at 0. And since we know what cosine looks like, it starts at 1. And then you do 2x equals pi over 2. So x would equal pi over 4. Since this is normally the first quarter point, now my first quarter point is at pi over 4. So it starts at 0, goes to pi over 4. We can probably make some guesses about the midpoint, but you do 2x equals to the midpoint to find where it's at. So 2x is pi over 2, or pi, and x is pi over 2. From here, what I would recommend is that you just use your pattern here. So it's 0, pi over 4, pi over 2. So you're going by fourths, 3/4 pi, and then 1 pi. So I do know that the length is pi. So my graph is going to go starting at 1, cuts down through the axis, has a minimum at -1 down there at pi over 2, back through the axis, and then up. And then that's what's going to keep repeating over and over. And so you can see the period length is from 0 to pi. In this case, I start at 0, my first quarter point is at pi over 4, and then at pi over 2, and you can just scale it out, 3/4 pi and then pi. Okay, these are considered just the one cycle of the graph where you're starting at the origin. All right, now let's look what happens when we are considering this argument where there's a shift in my graph. There's a phase shift. My amplitude is 1. Period length is still 2 pi here because it's 2 pi divided by 1. But my phase shift here, this means that it's to the right, pi over 2. So everything's going to be moved to the right, pi over 2. This is what my graph would look like. This is, let's say this is my x and y axis. Normally the cosine starts at 0, but now it's starting at pi over 2. And what you can do is go x minus pi over 2, and you set it equal to where it normally starts 0, and then so this is the initial point, pi over 2. That's my starting point. We're just going to do a couple of these, and then you do x minus pi over 2 equals pi over 2, which generally would tell us, this would tell us where the first quarter point is, so that is equal to pi. So I know my next mark is pi, and cosine starts at 1, then it hits the x-axis. I can go by my scale here. If my distance between these two is pi over 2, then this would be 3/2 pi over 2. So the next mark is 3/2 pi over 2, or 3/2 pi, and then the following one would be 2 pi, and then the final one would be 5/2 pi. I'm just counting by halves, so 1/2, 2/2, 3/2, 4/2, 5/2. And here's what I would do to graph. So I've got my initial point, where it crosses, has a minimum, crosses again, and then back to the top. But when you draw this, you want to make sure that you include the curve as it passes through all of those key points. So that's just the one cycle of it. Now obviously what happens is it continues. But you can see here that this graph has been shifted. It's a cosine curve, but it's been shifted to the right from here to there, pi over 2. All right, in the next section, we are going to focus on graphs that are tangent, cotangent, secant, and cosecant.